Hello and welcome. In this video, we want to take a look at preliminary steps required in order to train your own deep learning-based classifier with MVTec HALCON. First, you should understand the differences between the pre-trained networks provided in HALCON. Additionally, you need to prepare your training data by labeling and pre-processing the images you want to use. HALCON 1712 provides two pre-trained networks called the compact network and the enhanced network. These networks have been trained with hundreds of thousands of labeled images. Both are highly suitable for industrial applications. However, when facing more complex classification problems, the enhanced network is more versatile. On the other hand, both the training and the classification are much faster when using the compact network. Traditionally, when working with machine learning, you had to manually select the features that most effectively separated the classes. This complicated task does not exist when using deep learning. During the training, the network automatically determines which features to use. Therefore, when using HALCON's deep learning, all you have to provide are your labeled images. There are two requirements, however. First, you have to provide a large number of images for every class, so that the classifier can robustly learn the features. Based on our experience, we recommend at least 500 images per class. Note that this number is highly dependent on the classification problem. Additionally, you need to pre-process the images. The reason is that the pre-trained networks require the images to have a specific size and RGB value range. Furthermore, you may want to add some application-specific pre-processing. For example, here we want to remove as much background as possible. Let's have a look at how to prepare the images in HDevelop so that you are ready to start your own deep learning classification application. This code is based on the deep learning examples, which are included in your HALCON installation. We highly recommend these examples as a starting point for your own application. Let's go through this code step by step. First, we need to read the data we use for the training. In the context of deep learning classification, data represents the images with their respective labels. Before starting this example, we organized the images as follows. In the directory PIL, there are three subfolders containing the three classes: good, contamination, and crack. Using the procedure readDLClassifier dataset, we list all images in the directory PIL. For each image, the label is extracted, using the name of the last folder as label source. The result then looks like this. For all three PIL types, all three classes are extracted correctly. Next, we read the pre-trained network. For this simple classification task, the compact network is well suited. However, since both networks have the same image requirements, you can simply try both when training your own classifier. At the end of this program, we want to save the pre-processed images. This way, we don't have to repeat the pre-processing when using images multiple times during training. To prepare for this, we create the directories for the pre-processed images with this local procedure. Then we prepare the new image names. Note that HALCON objects are suitable here because they are very fast when writing and reading a lot of images. Next, we read all images successively in a loop and pass them to this pre-processing procedure. Having the pre-processing in an application-specific custom procedure is highly recommended. This is because the images that are classified later on using this network have to be pre-processed in the same way as these training images here. In the procedure, there are two important parts. The first part is customized for this application. Using blob analysis, we crop the images to reduce the background. This can improve the classification results. If your camera image were to look like this, you would have to segment the PILs first. As you may have guessed already, it's important to have only one object per image for an application like this. The second part is the same for all applications. Using the procedure preprocess DL classifier images, we preprocess the images such that they fulfill the requirements of the network. Internally, this procedure reads the requirements regarding, for example, the image size and RGB value range, and adapts the images accordingly. Since the resolution and aspect ratio of the images have changed, it's important to check whether the classes are still distinguishable. Otherwise, you may have to divide the image into multiple parts, then label the parts separately and train the classifier on these image parts. Lastly, the image is written to a file. This process is then repeated for all images. This concludes this tutorial. Next, you can check out our tutorial on training your own deep learning-based classifier using these images. Thank you for watching.